Welcome to the Stormsurf video surf forecast for the week starting Sunday, October 25th. Looking at significant wave heights for the North Pacific Ocean, we see an improving and active pattern. First off, small gale working its way into the Pacific Northwest has already generated swell that is reaching Central California. Wave heights at its peak were pushing 13 feet on the face as of Sunday afternoon. Hurricane Olaf, minimal hurricane, is still circulating east-northeast of Hawaii and is to slowly wind down. A new gale, actually a storm, in the Gulf of Alaska has formed with 42-plus foot seas. We'll get into that in a minute. And yet another system is developing off the Kuril Islands, expected to push east, creating yet more swell. Indeed, an active pattern is in play. But first, let's take a look at jet stream level winds. These winds help support the formation of storms, and when those storms do form, help direct their track. This is up about 30,000 feet. So, what we have, we're looking for troughs. That is a dip in the jet stream, just like this, and just like this here. And you want a good amount of winds feeding into the apex of that trough, actually the bottom of the trough, just like we have here, 190 knot winds, very strong, well-formed trough here in the Gulf of Alaska. This is what is helping support the storm that is generating 40-plus foot seas right now in that region. We also see a bit of a trough here off the U.S. West Coast. That helps support a gale that has produced swell that is hitting the California coast right now, a very local system. And yet one more trough digging out, not as good wind support here. You really want it in the western quadrant falling down to the southern quadrant. Not as good wind support, but still a trough nonetheless. Indeed, an active pattern. Let's put this into motion. The Gulf Trough starts pinching off. It's very close by even Monday. And then we got this sort of a split thing going on off the California coast. And then the trough in the Kuril Islands continues. Nothing super impressive, and this sort of rolls out. And then things look a little bit more organized come, say, Tuesday night or so, or Wednesday. Another trough develops, the remnants of the one that was off the Kuril Islands. And that would help, just looking at it, support gale formation as well. And then it sort of fades out a little bit as we get into Friday. The interesting part to note here is the jet stream is just starting to dive into California. A little bit of a ridge here. That would probably support high pressure off here. And there's a trough inland here. Anyway, still, the bulk of the energy is down right around 40 north, going more or less straight west to east. Roll this out some more. We're into the weekend. Kind of a muddled pattern. The jet gets kind of split here. So the trough that appears apparent here, when you got winds running over top of it, it becomes non-productive. A lot of times it'll just turn into high pressure in the middle. Roll this out to 180 hours. And then sort of look at this, a bit of a split in the jet here. That's not good. And it tries to come together, but it just quite can't figure out what it wants to do. Let's go look down at the surface and see what the impact of these upper level winds are. So here's our current situation. Surface level pressure, surface level winds, remnants of the gale that created the swell that's hitting California, moving into the Pacific Northwest. Olaf here, east-northeast of Hawaii. Gale, actually storm number one, look at that. What is that? 55, 60 knot winds. That's almost hurricane force. If it was 65 knot winds, it'd be hurricane force winds in this one. And then another good patch of 55 to 60 knot winds here. But notice they're behind the Kuril Islands, completely landlocked. So it's only this little bit of fetch out here that is actually capable of generating seas. And then also the remnants of what was, I believe, Super Typhoon, or at least Typhoon Champy, hanging here, getting integrated into this cold core low, losing its identity completely by now. Let's put this into motion. As we continue into Monday, the system in the Gulf starts winding down, but still 60 knot winds will not be denied. You will get solid swell out of that. The wind speed alone should get you an 18-second period swell. Also notice that Olaf looks like it's trying to get integrated into this cold core system as well. And then this dual Champy here and the cold core low here continue on. Roll this into motion, and generally things fade out. Now notice Olaf here approaching the U.S. West Coast. Earlier runs actually had Olaf at tropical storm status, pushing into like the Monterey Bay area, which was quite comical. We didn't believe that would ever happen, but it's still sort of hinting at something like that. Anyway, broad area low pressure, totally taking over the North Pacific, but really it's just this fetch here that really is offering much in terms of swell generation as we get into Wednesday. And then the whole low, broad area, we should go back there, right? Broad area 30 knot winds, but that's only good for maybe 12-second period wind swell. Good for Hawaii, certainly aimed right at them. And then we roll this out, and that guy just fades off. Notice we have high pressure here, just like we saw in the jet, and strong winds along the coast by Friday and Saturday forecast, and then that sort of starts petering out, but there's really not a whole lot going on. It's that sort of split pattern in the jet isn't really conducive to storm development. Let's go take a look at the effects of those winds on the ocean surface. So here we are, significant wave heights for the North Pacific Ocean. Our storm currently in the western Gulf of Alaska, max seas 43.6 feet. A little bit north of ideal for the Northern California area, but still very solid indeed. And then, of course, our other systems developing that we talked about. Roll this out. This system continues by, this is actually about right now, 0Z Monday, 43-foot seas, and then dropping to 42-foot seas. At one point, this was up to 47-foot seas, but still quite respectable. Supposedly, that's about 39-foot seas there, and 42-foot almost by 12Z on Monday. And this guy starts winding down the Gulf system while the one off the Kuril Islands pretty much does its thing in the 39-foot range. And notice this is all aimed very well at Hawaii. Hawaii should get a good solid piece of swell from this one. And we'll go take a look at the Great Circle charts here in a minute. And then it pretty much fades out as it goes across the date line. Still much seas being produced into about Friday, large area 20-foot seas. Swell certainly will arrive on California too if this thing plays out as forecast. And then things kind of settle down. Still some activity in the Gulf, but rather minor compared to what's happening right now. Here's our Great Circle tool. We're going back in time just a little bit to Friday of last week. Notice this little gale here off the North California coast. It organized maybe 22-foot seas on a very westerly track, like a 292-degree track into Northern California, going up to about 290, what's that, 296 or so, and then fading out. That, with just that little thing, is what has created the swell that's hitting California right now. We'll get rid of that, and then we'll get into where we are right now. And here we go. Here's our existing system, 18Z Sunday, relative to Northern California on about the 300-degree track, relative to Southern California about the, it looks like about the 304 or 305. And then relative to Hawaii, here we go, very northerly track. That's about 360 right there, and kind of hard to read the numbers here, but that's about 350 or so into Hawaii. We'll just sort of, it's actually falling a bit south towards Hawaii, though most of the wind energy looks like it's pushed more towards California. Anyway, that thing pretty much does its thing, but we go back here. Let's also take a quick look at the gale off of the Kuril Islands. That's the 313-degree track, 312-degree track, pushing right down there very well towards Hawaii. We'll just roll that out there so you can see that. And then let's play the same game again, but do it relative to California. We'll just pick Northern California. And you see already this is about the 302-degree track, and it sort of falls. It's not really aimed at California. It's sort of cutting across the Great Circle paths as we go here until we get to towards the end here, and then in the 288-degree range, a little bit of energy. Regardless, there'll be swell for California from this system as well. And one more tidbit of data. We were looking for JSON-2 satellite passes over the gale in the Western Gulf. We have not had any so far, but the one for the system off the Kuril Islands, we got one pass here. That's about, 34-foot seas per the model. The adjacent two satellite passed right overhead. It got an average 15 reading average at 35.5 feet here, with one individual reading to 39.8 feet. So it's actually doing better than what the models suggest. That's good news for Hawaii. That means more energy heading that way. And then a quick look at the forecast track for Olaf, currently right here. Hawaii's off to the side here. Winds 80 knots, seas 25 feet. And you can see it's forecast by this evening, still barely hurricane strength. And when we get into Monday, tropical storm strength, 60-knot winds, and fading pretty quick from there. And this chart actually has it recurving and sort of heading back towards Hawaii as a tropical depression. In terms of swell generation, probably not a whole lot for the U.S. West Coast, and whatever does get generated will be buried by the larger, stronger, longer period swell coming from the Gulf of Alaska. But this is generating sideband swell for the Hawaiian Islands, and any swell is good swell. And then we'll take a quick look at the southern hemisphere just to see what's going on, but really not a whole lot happening. The pattern is decaying. Still, whatever there is, it's all tracking under New Zealand. This all attributable to El Nino. High pressure set up here. Low pressures come under, systems travel underneath it, form a pressure gradient that generates higher than normal winds, which generates seas, and they just push right up this track right here. That's classic El Nino sort of setup. One would expect that to fire up significantly come next summer as well, and we should see a very dominant New Zealand storm track, at least for the early part of the summer. Anyway, so we roll this out. We're just looking for a week out. A little bit of a gale here maybe next weekend, but just it pretty much is winding down now. It's been actually a great summer. Consistent New Zealand storm corridor. If your breaks are breaks that favor that swell direction, it's been a banner year, and that's a good thing. Next up, El Nino 2015. Let's dive deep into the details. And we'll do this presentation like we have weeks past, focusing first on wind anomalies in the West Pacific, because those wind anomalies, when you have westerly anomalies, they generate a thing called a Kelvin wave. They help push warm water to the West Pacific to the east. That warm water travels under the equator at depth, creating a thing called a Kelvin wave. The Kelvin wave eventually erupts to the surface in the area of the Galapagos Islands in Ecuador, warming surface waters in that area, and then trades in the Far East Pacific on the equator carry that warm water to the west into the area called the Nino 3.4 region, roughly between the dateline and south of California. And when you have a consistent, long-standing pool of warm water there, that helps feed the jet stream, make the jet stream stronger than normal across the North Pacific in winter months, helps fuel storm development there. And of course, everyone knows that El Nino in winter months in the North Pacific is very good for swell production. All right, current situation. No westerly winds, or just a little bit of westerly winds here per this from the TAO buoys, his actual buoys on the ocean surface. And then, but relative to normal for this time of year, still westerly anomalies in play, meaning more warm water being transported to the east. And here we are, the GFS model, high-res GFS, looking at what we call the Kelvin wave generation area, roughly 5 north to 5 south, from about 135 east, this is just north of New Guinea, all across the dateline, a little bit beyond. What we're looking for is either westerly winds or calm winds. We see basically a generally calm wind area, a little bit of westerly winds here on the dateline at 18Z Sunday, and we'll just roll this out. And basically the pattern is a very light wind pattern in the Kelvin wave generation area. Here's a little bit more westerly winds here over the dateline come Thursday or so. But even just neutral dead winds like this, because there is no trades, then that is effectively westerly anomalies, and that again transports warm water in this area off to the east at depth. Roll this out, and just it continues to be basically dead winds in the Kelvin wave generation area for the next week. We've also modified the model. We've created a second one, so there's 2 westerly wind burst models now. This provides the view of the eastern Kelvin wave generation area from the dateline to about 170 or 165 east. And here are the westerly winds that are currently in play. What is that? About 14 knots peak, which is pretty good, and that continues in bits and pieces here. Let's see, till about Tuesday night. By Wednesday, then we're back to dead air in the Kelvin wave generation area, and I believe that just continues like that through the end of the period, which is not as impressive as what we had maybe a week ago and had been going on for 6 weeks, which was just steady nonstop westerly winds in the 15-knot range. That's a full-on certified westerly wind burst, but that has died down. Now we're in sort of a little bit deader sort of period right now, but that's not bad. We've had a lot of warm water being transported to the east. And here's yet one more view. This is actual westerly anomalies for, let's say, the past 4 or 5 days. Right here from, actually, the Kelvin wave generation area starts here about 1:30. There's New Guinea. Over the date line to about here. Notice there was a lot of westerly winds or anomalies east of there, but you do not get the Kelvin wave support once you get past about 165 east. Anyway, we roll through, and you can just see this persistent pattern hanging on the date line, and that has, and that's still sort of going on, but not as strong as it was a week ago. And here you go. This is a different sort of view, but basically the Kelvin wave generation area goes from here to over to somewhere in about here, and then notice this here. West of the Kelvin wave generation area, you have easterly anomalies. This is over like the Philippines and that sort of area. And this is classic El Nino setup. Westerly anomalies right on the dateline region and a little bit west of there. This is our big westerly wind burst we talked about that started basically the end of September, went to almost the 16th or so. And now notice this. Here's another westerly wind burst. We saw that on the westerly wind burst model. This is the portion of it that's like in 170, just in the far eastern Kelvin wave generation area. And then that's supposed to fade out about a week out. Anyway, the point being, this westerly wind burst here, and add a little bit of this here, is very similar to the major westerly wind burst that occurred in the late June, July timeframe that made a massive Kelvin wave that is causing significant warming in the surface equatorial Pacific right now. The expectation is this one will do very much the same with another major Kelvin wave number 4, in flight now. This is very good and could help to support the development or help to elongate El Nino. So basically, if this westerly wind burst, we'll just say roughly, October 10th was the core of it. It will take 2.5 months for the resulting Kelvin wave to hit the Galapagos. So what would that be? October, November, December, let's say Christmas time, that Kelvin wave starts erupting. And then it'll take another month after that to make it into the Nino 3.4 region, so that would be the end of January. So it's possible that we could have significantly warm water in the Nino 3.4 region from now till the end of January, if not a little bit beyond. That would do very much to help push this El Nino even stronger than it already is. So here's another forecast. We've seen this one before, a little bit different. The past is down at the bottom and it goes to the future towards the top. Again, Kelvin wave generation area, roughly draw a line from here over to somewhere around in here. So here was the big and the red boxes are the active phase of the Madden-Julian oscillation. The big westerly wind burst we talked about in the June-July timeframe is there. The reds are westerly anomalies, or actually westerly winds. The yellows and oranges are westerly anomalies. So we had a big westerly wind burst there. That Kelvin wave is erupting right now. It's actually past its peak. We believe it peaked out on about 9/19 or so. So roughly, let's play this out. 2.5 months from, let's say, the 1st of July. That would be August, September, about mid-September or so. And that is exactly, and we could show some data later, when the current Kelvin wave eruption peaked out, and now we're on the downside of that. Anyway, here is the next westerly wind burst number 4 that has occurred in October, and we've already talked about the timing of when that Kelvin wave might erupt in the Galapagos. And then we move to where we are now, again supported by supposedly the active phase of the MJO, but we really don't believe that's the case. We believe it's more just a case of the El Nino base state sort of being supercharged a bit. Anyway, the forecast is for an inactive MJO and weaker anomalies starting about the end of October, Halloween, and then going on into about the end of November. And then westerly winds kick up again. And also, let's get this, equatorial Rossby waves. You see, as you get these Rossby waves that go from east to west into the picture, they help support at least a little bit here, westerly winds that are currently happening, and then maybe another bit of slightly enhanced, but the reality is, we'll just do it this way, it is the El Nino base state that is really the driver of westerly winds forecast to continue into December, into January. And the other interesting part is the core of the westerly winds have been roughly right on the date line. They start moving east, but they're not significantly east even into January. And there should be enough westerly anomalies to continue to push warm water to the east, which is kind of a little bit of a head scratcher, but also kind of encouraging. It might suggest that this El Nino might be a very long-lasting El Nino. Anyway, that's the forecast, long-term look. Of course, I would never believe a model that goes out months into the future, but it gives you at least a baseline, and we are tracking this in our written reports on stormsurf.com. Tracking, the every couple of days changes, but this pattern has been locked in this model for a good long time now, so maybe that increases the odds that it might actually develop this way. All right, so we've talked enough about westerly winds and the prognosis for westerly winds. What's the impact of those westerly winds? Well, it takes warm water that's normally piled up here in the West Pacific, starts pushing it to the east. Notice this, a big tongue of 29 degrees centigrade water temperatures pushing to 134, maybe almost 133 west, and the 28-degree isotherm, again, down, pushed to about 120. The interesting part here is the main Kelvin wave eruption site seems to be right around in this area, and we suspect that has a lot to do with the position of the 28-degree isotherm. Anyway, it is not so much the absolute temperatures, it is the deviations from normal for this time of year that help to define what a Kelvin wave is. Clearly, we have piles of warm water. Not quite as warm as it was. It was up to 7 degrees here at one point. Now we were down to one small pocket of 6 degrees. This is the results of Kelvin wave number 3. It's slowly starting to bleed off heat here as the warm water works its way up to the surface. But we've also had another westerly wind burst number 4, that is pushing warm water to depth, and you can clearly see it here. Another downwelling Kelvin wave being formed. Now, it's not going to be a distinct Kelvin wave. It's basically just going to be re-refreshing more as this warm water starts working its way off to the east. We'll probably see these temperatures go back up at some point and then start erupting at the surface again and feeding the equatorial warm pool. Anyway, a good, solid, healthy subsurface El Nino picture is in play. And here's another view. You can clearly see in this one, westerly winds here, downwelling, warm water, building Kelvin wave. And then here, we did see right here, these 4-degree anomalies. They're actually little fingers reaching up to the surface in the East Pacific, and you could literally see that on the high-res satellite photo as those warm bubbles started reaching the surface. You could see it. Now we don't see any of that, but we do see this large area of 3-degree anomalies basically going from about 145 to about 100, or basically from the Galapagos off to a point almost south of Hawaii. So keep that in mind when we go to look at some of the surface charts here. Basically, a very healthy El Nino subsurface profile is present. And yet some more evidence for the presence of warm water. JSON2 satellite data strip out all the waves, strip out the tides, strip out any other anomalies on the ocean surface, and what you find is there's this big bubble of where the ocean surface sort of bubbles up 15 degrees or 15 centimeters above normal. That typically is a clear indication of warm water at depth. Warm water at depth expands, creates this sort of bubble on the ocean surface. You can't actually see it, but the satellite can pick it out. It's extremely sensitive, sensitivity to about 1.5 centimeters or so. So clearly, warm water, again, here we go, from the date line to the Galapagos. Also notice these 5 centimeter anomalies were closer to the coast here in Ecuador. They are not anymore. Again, this is part of this theory that this year's El Nino is slightly westerly displaced. It's not erupting. You're not seeing Kelvin waves erupt between the Galapagos and Ecuador. There's warm water there, but it's not as pronounced as the 97 event. The 82-83 Super El Nino was super westerly displaced. This is speaking to the character of this year's El Nino, which clearly appears to be some sort of hybrid between 97 and the 82 El Nino. Both of those were Super El Ninos. We are not at Super El Nino strength yet, but we are getting very close. And then, of course, this chart. This is a great chart. Upper ocean heat anomalies. That is the top 300 meters of the ocean surface. This is, and you can, this is the West Pacific. This is the East Pacific. And basically, you can watch Kelvin waves migrate across the Pacific. Here's a Kelvin wave last year in the failed 2014 El Nino bid. Warm water moving west to east. Upwelling phase of the Kelvin wave cycle. Cooler water. And then, boom. A strong Kelvin wave number 1 of this year in March, Kelvin wave number 2 in June, and then the massive Kelvin wave we talked about in the June-July time frame created from the westerly wind burst in that same area. Large area of warm water, and now here we are. The current westerly wind burst has created yet another bulge in and building warm subsurface temperatures. We're kind of looking and getting anxious, wanting to see some 2.5 degree anomalies show up somewhere down here. Might be a couple weeks off still, but we would expect it to happen because that westerly wind burst number 4 was quite strong indeed, supposedly rivaling westerly wind burst number 3 that created this huge Kelvin wave. So something to monitor. All right, we've talked about westerly winds over in this region, Kelvin wave generation area. We've talked about subsurface temperatures, Kelvin waves migrating from here, warm water, under the equator, gurgling up and erupting in this area. And now let's talk about surface water temperatures, the effects of Kelvin waves as they erupt. Here's the current water temperature profile. Differences from normal. These are anomalies. Differences from normal for this time of year. A clear El Nino signal. That is warm water all along Ecuador, the Galapagos, and then being carried by trades out to the date line, creating this sort of warm tongue here. This is classic El Nino. We have not seen a profile this good except in the 97 El Nino. Even 82-83 didn't look this good, but the imagery was very basic back in 82-83. The world's come a long way since then. Anyway, also lots of warm water off the U.S. West Coast, unrelated to El Nino directly. This is more a symptom of the change in the Pacific decadal oscillation we believe that's going on. It's sort of like a 20 to 30 year El Nino or La Nina pattern. We've actually been through 15 years of a down phase of the PDO, which is the equivalent of like a 15-year La Nina. The thought is that is shutting down and that we're going to move into a more active pattern long term. We'll see if that really holds true. Anyway, cool water here off of Africa. Normally, this was much cooler here. When you get these strong El Ninos set up, you get cool water off here. And then as you get towards the fall, it sort of falls apart. The other thing is water temperatures here, north of Australia. You get high pressure here, and it basically just starts cooling the water. So you have a cool pattern here, warm pattern here. Normally all the warm water's here and it's cooler off here. So very good signal. Let's go back to October 1st and just look at the change. So here's, and look right in here, and we'll just go back and forth, back and forth. And what you see is there's this patches of cool water here. There's bits of warm water here in early October. And out here there was warm water, but not as strong now. Much warmer. Look at how warm it is right in there. And this is all solid in there. So the pattern continues to develop. A lot of this is attributable now to the eruption of Kelvin wave number 3 at the surface, and then the trades in this area carrying that warm water off to the west. That is fueling the jet stream to get stronger in the North Pacific up in here and helping to support storms. Nothing super obvious yet, but we think as we get further and deeper into the fall, the pattern will become much more noticeable in terms of the storm track. We'll do a quick scan of high-res imagery, Nino 1.2 region between Ecuador and the Galapagos. Warm water here, looking pretty decent, but not nearly as impressive as it was in July, and that was even before Kelvin wave number 3 erupted. So, again, this is where we start talking about this El Nino being westward displaced to the west, just because there just isn't as strong a heat signature in this area as one would expect if it wasn't displaced. And then we continue further west from about 120 to about 160 or south of Hawaii. Here's the warm water signature. These are all 2.5 degree or better anomalies with a little pocket of 4 degree here. Very solid. We go back 10 days, look at the pattern. It was thinner, not as robust. Now, wider, stronger, very solid indeed. And then we continue. Here's the date line. This is the last little segment. Here's the current pattern. Almost 2.5 degree anomalies, just about reaching to the date line. Go back 10 days. You can clearly see that things are getting much warmer out in here as well. This is all a very good sign. This is classic El Nino, exactly what we want to see. And here's the current high-res image from October 24th. Actually see little pockets here of 4 degree anomalies still erupting along the Galapagos. Let's go do a quick dive in there. And here we go. And notice this is actually interesting because these anomalies were not present before, but now we have a pocket of almost 5 degrees here right west of the Galapagos. Another 4 degree patch here and a couple little patches here. So this suggests that even though the subsurface picture we looked at, and remember we talked about it being warm from about 100 out to about 120, I believe it was, or so. So there's still these periodic pockets coming up subsurface erupting. Now, but to show you how things were back here, we'll just do it. On the 19th, here is when we suspect the peak of Kelvin wave number 3 erupted. This is what it looked like. Here's where we are now. Certainly a shadow of what it was, but still, in any normal year, if you saw this, we would be very excited. So this is all good news. And yet one more chart. This shows you the trend of the past 7 days. And sure enough, here are those warm pockets starting to show up around the Galapagos, and then kind of a neutral pattern. And then the yellows are just weak warming here out towards the date line as well. But just basically all holding its ground, if anything. So what's all this mean? Clearly, Kelvin wave number 3 is erupting, still continuing to erupt. Still lots of warm subsurface water, and Kelvin wave number 4 building in underneath. So this warm pool is expected to hold, and the longer it holds and the warmer it gets, the more effect it will have on the jet stream. In fact, so let's look at Nino 1.2 area. This is just all the grid squares in the Nino 1.2 area using CDAS information. And clearly we had talked about this being westward displaced El Nino. This chart shows it. Temperatures are actually falling roughly 1.4 degrees above normal, which is nice. Respectable. In any normal year, we'd be very excited, but not that big of a deal. But differently, the Nino 3.4 region, this is the area that really matters. Down a little bit here at 2.28, but it was up to, what was that, about 2.4 degrees roughly here in this range, which is extremely warm. If it could hold that for a month, we'd blow the doors out of the 97 El Nino. We don't expect that to happen, but we would expect to see temperatures in about the 2.2 range or so, and that would put us in very close to super El Nino status. In fact, we got a hold of all the raw data that was here in this whole spread. Levi Cohen from Tropical Tidbits provided that to us. We went and did some averages. What we're really trying to do is get an early look at what's going to come out for the October Nino 3.4 numbers. And what we came out with was 2.2 degrees. If you took all the data from October, from here out to here, the average was about 2.2 degrees. If we could see temperatures like that for a 1 month average, that would be very impressive, because that would put us right in the ballpark with 82, 83, and 97, the only two super El Ninos in modern history in the satellite era. And that's where we expect this El Nino really is. It's nestled somewhere between the two of those. And you've seen this chart before, but here is the 97 El Nino 1 month peak, and the numbers we're using here are 1 month averages. 2.32. The 82, 83 El Nino was 2.21. Last data we had for this year's event was 1.67 in September. In October, we're thinking we're going to be up in here somewhere in very good company with very strong El Ninos. The point being, this year's El Nino, by any standard that we can see, is a very strong El Nino. And finally, El Nino means nothing if all that warm water in the equatorial Pacific is not coupled with the atmosphere, is not having an effect on the atmosphere, then it means nothing. But always it does when you get a good, healthy, warm water pool like the one we're seeing. So the Southern Oscillation Index, difference in pressure between Darwin, Australia, and Tahiti. Negative numbers represent at least the active phase of the MJO. If they persist for a long period of time, which they have been, then it's a clear sign of El Nino. The more negative, the better. We had one good, really deep one-day reading of -42. Current day's reading, -14.80. But it is not so much the daily numbers that matter, it's the trend over time. The current average, -21.34. When you're in the -20 category for a 30-day average, you're in great shape. In fact, we had a new low, I believe it was right in here at -22.61 for the 30-day average, and we're holding pretty well there. We say if you're at, and then here's the 90-day running average. We've been saying if you're at -18, you're in strong El Nino status. Clearly, we're there at -19.12. Diving down a little bit, it peaked out here roughly right here, and I think it did it a little bit earlier too. But anyway, you get the general picture. Strong El Nino numbers here. So next we talk about the ESPI. This index, instead of measuring the difference in pressure between, actually it'd be Darwin down here more and Tahiti over here, this is differences in precipitation patterns. During El Nino, you typically see a lot of precipitation over here in the Central Pacific and a very dry pattern over Indonesia, where in a normal year the pattern is reversed. So here's the actual satellite imagery. Clearly a drier pattern over Indonesia, clearly a wetter pattern over the Central Pacific. You can take all the grid squares in here, average them out, come up with an index. The current daily index 1.98. That's for the last 30 days, and this updates daily, though. It's been hovering right around in the 2 range, maybe as high as 2.4 or 2.5, but really hasn't gone much below about 1.8. Very strong correlation, and we've shown you these charts before. It's not updated here, but the 82-83 El Nino was about a 2.2. 97 El Nino was about a 2.6 or so. So we'd still like to see these numbers go a little bit more positive, but we're in very good company with the strongest El Ninos at this point. And finally, forecasts for the Nino 3.4 region, sea surface temperature anomalies. This forecast is almost a joke. PDF corrected. We were actually hanging our hat on it for a while. Now we've backtracked. It suggests water temperatures peaked out on October 1st at 2.2 degrees. We believe that not to be true. The non-PDF corrected version here is looking a little bit more realistic, suggesting peak temperatures in probably the November time frame. Actually, again, looks like it's pushing up here late. We see some members pushing into the 2.8 degree range, though right now it looks like the forecast is for about 2.6 or 2.65 in the November time frame. We'll see what happens. The numbers, the Nino 3.4 actual numbers, again, are only monthly numbers, so we're kind of anxiously waiting for October to be up, see what the numbers are, and see how we compare to 97 and the 82 El Nino events. But as of right now, the general consensus is we're in very strong, if not super El Nino territory, and it's kind of just waiting to put the icing on the cake at this point in time. So to wrap it up, North Pacific jet stream looking very good. 2 storms in effect, swell being produced, likely targeting Hawaii and the U.S. West Coast. El Nino doing very good. Water temperatures are at historic levels, rivaling super El Nino status. That's our best guess. We need hard data before we'll ever say that. But certainly, the picture is very encouraging. We're really just waiting now for those warm waters to couple better with the atmosphere, really start supercharge the jet stream. As we get deeper into fall, we expect that to happen. The preponderance and occurrence of storms in the North Pacific should be picking up, which of course would mean more surf, larger surf, longer running swells, and then at some point the floodgates would open and precipitation would start working its way into California. But we don't expect that to start happening probably into the late January, February timeframe. In the meantime, it's a lot of anticipation, but the general consensus is things are going very well and we're on the right track. So that's it for this week. We'll do it again next week, same time, same channel. Thanks for watching.